see that this thing was my
Oh,
mic was
it's
muted.
muted now. Okay. Had your food, sir?
Yes, sir. Yes, sir. I had my food, sir. Yes,
Okay, okay. Manas, have you joined?
Yes, sir. Yes, sir.
Okay. Good afternoon, dear participants. Welcome back and welcome to the fifth session of Faculty Development Program on Data Sciences. And now I invite our research scholar, Manas Rahman, to introduce the resource person.
Thank you, sir. Good afternoon, everyone. So today, last session we have sentiment analysis in facilitating pandemic preparedness, and it is handled by Dr. Prakash Babu Kodali, and he is Assistant Professor, Department of Public Health and Community Medicine, Central Institute of Kerala. He is one of the public health researcher and educator with over 6 years of experience in public health research and teaching. He teaches infectious disease epidemiology and biostatistics and health economics for MPH students. He also teaches secondary data analysis and scientific research software such as statistical package for social sciences and EndNote. Till date, he supervised 20 MPH students towards successful submission of and defense of MPH dissertation research. So, without any delay, I would like to call upon Mr. Dr. Prakash Babu sir to start the session. Sir, please.
Yes. Thank you very much, Manas. Thank you very much, Kumar sir, for giving me this wonderful opportunity to interact with the participants. So, very good afternoon, everyone. I hope I'm audible to all of you. Really sorry in case if there is any technical issue from my end, and it's an honor for me to be here to to present some of my observations and findings and understandings about sentiment analysis and its application in case of diseases and healthcare, particularly COVID-19 pandemic, with the esteemed audience like you. I see that there are several professors, there are associate professors, there are assistant professors, several research scholars, faculty members, esteemed members from different esteemed institutions across the country. So thank you very much for being in the faculty development program here, and thank you very much for giving me this wonderful opportunity. So I believe that I'm trying to share my screen. Please let me know in case if there is any trouble. So yes, I believe that my screen is visible to all of you. Yes, I think that is visible. Right. So
yes, sir. Visible.
thank you very much, sir. Thank you very much, Kumar, sir. Right. So without any further ado, let me introduce myself. Myself, Dr. Prakash, and I hold a PhD in public health and an MPhil in public health and an MPH. I work at the Department of Public Health and Community Medicine, Central University of Kerala. My major areas of research are digital health, health system strengthening, infectious diseases, and epidemiological studies. And my major work, including my PhD work, focuses on the adoption of digital health technologies, particularly the mHealth technology. So uh, I'm also working along with one of the networks, which is looking into the epidemic preparedness and particularly by using the machine learning tools. I'm not a programming guy, but I'm a person who largely looks into the application of machine learning, AI, and big data related interventions into the field of healthcare and how they help in improving the healthcare delivering and performance of the healthcare system. That's the larger, work that I do and I try to look into. So coming to our idea, like today's topic of discussion is sentiment analysis in facilitating pandemic preparedness. So by and large, all of you or most of you would know about it, but to just skim over the idea and to refresh ourselves, we'll try to understand it in a greater detail. So the concept of sentiment analysis, the idea of sentiment analysis is what do you say, is a data mining tool, and it is also called as, it has several different names, as you all know: opinion mining, emotional AI, and even nerve that is being coined. So it's a tool that has been used. It's a natural language processing tool that has been used quite extensively for quite some time, and it is a tool which is usually used to identify, extract, and analyze subjective information. How do we feel, right? What is our opinion? What are our perceptions? So to identify and extract and analyze this kind of a subjective information, the information which is not in terms of objective numbers, ones and twos, but the information which is in the text format, to identify and analyze this kind of information, sentiment analysis is often used. And interesting part of sentiment analysis, or which makes it a very important tool to be used, is that the sentiment analysis enables the identification of the emotional tone behind a larger body of text. Take an example. We talk about, say for example, a big, user review, like, or a tweet regarding, say for example, COVID-19, right? So by analyzing that particular tweet, we can actually identify what is the emotion behind it. By analyzing hundreds, or maybe thousands, or maybe millions of tweets like that, we can identify the emotion behind the larger body of tweets, or the larger population who are tweeting about that particular problem, like COVID pandemic, isn't it? So we can identify the emotional tone behind the body of text, and based on it, we can probably come up with newer suggestions, newer interventions. And sentiment analysis also helps in identifying a polarity and the subjectivity of, or objectivity of the statements, and intensity of the emotions as well. Like, so polarity, basically, there could be, you all might have heard of it. You have polarity with regard to the positive, negative, or a neutral idea that has been promoted, or that has been subjected, right? So the field of sentiment analysis, particularly, or the tool of sentiment analysis, to be very specific, has its application in many different areas. One important area it has a profound application is marketing, particularly the managers who are taking care of big enterprises. They do rely on sentiment analysis to come up with some very interesting predictions, and some to come up with some very interesting methods by which they can address the issues. For example, let's take ride sharing platforms, Ola, Uber. I believe that we all know about these ride sharing platforms. So if we talk about the problem, or if a CEO, or if a particular manager in one of these ride sharing platforms want to know about, what are the most common problems that my people, or my riders are facing, or my customers are facing, the simple way by which he can understand them is through doing an analysis of all the reviews that he has received, or all the tweets that has been made with regard to Ola or Uber, isn't it? And if he tries to actually look into the frequency of if he tries to actually do an analysis and try to look into the frequency, he will see that there are several complaints. One of the complaints is frequently the rides get, what do you say, the driver is not responsive, or the driver is not safe, or the driver is not talking properly, or the rides get cancelled on the drivers and very frequently, or there is a delay in picking up, right? So there could be some common problems which might be found out, and these problems could then be addressed at a managerial level or at a ground level, and thereby improve the revenue of that particular organization on a long term. Right. So sentiment analysis is a common management tool. So slowly, what we have seen these days is that post-pandemic, more rapidly, and pre-pandemic as well, right from 2010s, there has been an emergence of data, or emergence of published data with regard to use of sentiment analysis in healthcare domain. And after pandemic, this number has only increased. So to give you an example of why sentiment analysis has become a prominent tool today in terms of the intersection between the healthcare and the field of information technology is that, in March and April of 2020, this is the time when, the world was in fear, isn't it? The stock markets around the world were falling like anything because COVID has been now declared a pandemic, and India was, moving into its lockdowns. India was in its lockdown, one of the stringent lockdowns in the modern history. And during this time, during this period of March and April 2020, there were over 3 million tweets which were made concerning COVID. More than 3 million tweets which were made concerning COVID. That is more than 30 lakh tweets which were made concerning COVID. And out of those more than 30 lakh tweets, more than 40% of them, so more than 40% is more than 1 million, more than 1.2 to 1.5 million tweets were actually sharing the health information. So there is a large chunk of health information which is being shared on tweets. There is a large chunk of health information which is being shared on posts. There is a large chunk of health information which is being shared on, what do you say, forums. And this information which is being shared on forums as tweets, as posts, actually serves as data for healthcare behavior. Just give me a second. This serves as data for healthcare behaviors. For example, one of the common behaviors that we see these days with regard to COVID-19 is, masking, right? And an important behavior that we see these days about people to post is something which is called as vaccination, taking a jab of vaccine, isn't it? And encouraging the others to take the vaccine. So all these posts about COVID vaccination, which are done by the people, which are posted by the people, either taking the vaccine or talking against the vaccine, talks about what? Talks about, gives an understanding about something which is called as the acceptance of a vaccine or a hesitancy of a vaccine. And on a longer run, if you can actually map in across the cities the acceptance or hesitance, you can actually say that, okay, fine, in Mumbai there are large chunk of people, this is just a hypothetical example I'm giving. In Mumbai there are large chunk of people who are against the COVID vaccine, so the vaccination numbers could be low there. So we need to target more people, we need to be more proactive in terms of vaccination strategy. Whereas in Hyderabad, people are taking vaccines in a good way, and people are more positive towards COVID vaccination. So there is a positive acceptance behavior. We have to continue our interventions that we are going with in the same pace. So you can make some tweaks to the program. You can make some strategic changes to your program based on some of these things, because a large chunk of health information is being shared, and all of this health information is nothing but your data, which is ready to be mined, which is ready to be analyzed, which is ready to be interpreted and guide policy in order to make an evidence-based decision. So why it gains prominence today, like the why of sentiment analysis, why it gains prominence today? So when we try to look around, like, our mobiles, our computers, the activity that we are doing online, it is generating numerous quantities of data of variable quantity and a variable quality. You all know more than me with regard to it, right? And we are living in this web 2.0 kind of a scenario where there is chunks and chunks of user generated content. There is, tons of MBs or tons of TBs of user generated content, which is, being generated every day. And all this user generated content is analyzable, is usable to, target interventions, or majority of times it is used to target ads on another end, if we talk about it from a marketing perspective. And largely we see that across the world, social media and web-based retailing platforms are percolating to a great extent. They are reaching the most extremes. So as an example, in Indian context, if we just take an example, there are more than 447 million users of a platform which is called as WhatsApp, right? And there are several million, tens of millions of users of Instagram, tens of millions of users of Twitter, millions of users, hundreds of millions of users of Facebook, and all these people are posting, and all these people are providing information. There are millions of consumers on retail platforms like Amazon, and when these consumers buy, they do post. And interestingly, there are a lot of medicines and medical products now who are going online, which are going online. I believe that if it is not an exaggeration, a good number of you or a majority of you might have uh, seen an increase in telemedicine services, right? The services which are provided through uh, mobile phones, the consultation of doctors being provided through mobile phones, through apps like Tracto, through apps like eSanjeevan, buying masks or buying what do you say, oximeters, pulse oximeters, or buying PPE kits through Amazon. They are medical products, isn't it? Buying medicines over NetMeds. So medicines and medical products are nowadays going online to a great extent, isn't it? And there is a need to improve the quality of care, improve affordability and identification of what. So all this health information which is being posted out there helps in identifying the bottleneck, helps in identifying the best practices if they are, helps in identifying the areas where the interventions are needed, and helps in identifying the means, identifying the areas where we can target a specific intervention and make sure that the improvements in health is. Best example again I would like to cite is the oxygen crisis which happened during the last year's uh, that is over Delta waves COVID crisis, right? Delta waves oxygen crisis. We have seen it, right, in 2021. If you see Twitter during those 15 days, during those 20 days, during those 1 month of time, you can see that there are hundreds of thousands of tweets which are SOS tweets, which are emergency tweets, which are regarding specific drugs, which are regarding shortage of specific drugs in some places, which are regarding shortage of oxygen in some places, which are regarding, a surplus of oxygen in some places, and one helping with another. So these information are actually helping us to identify what are the areas, what are the regions where more, for example, if you are getting more tweets from Delhi, more SOS tweets regarding oxygen shortage in Delhi, whereas if you are getting a lesser number of more surplus tweets regarding oxygen surplus in Lucknow, there is, we can actually identify from where these are coming, and we can actually, provide, make the logistic arrangements as well. And interestingly, there are cases where such kind of arrangements are also being. So we can say that this simple disaggregated social media information, the simple disaggregated social media information can act as a large chunk of data, right? In addition to all of it, there is also one big problem with social media, and we all know it. That is misinformation, and in epidemiological terms, we call it infodemic. So I would like to highlight as a small example here of the tweets concerning coronavirus. So, for example, this one tweet out there that we see from June 2020, which says that coronavirus is because of 5G. There is one scientist, so-called scientist, who says that the hand sanitizer does not work on coronavirus because coronavirus is a virus, whereas hand sanitizer is antibacterial. So don't wash hands. And that happened on 1st of March 2020, and afterwards how the things has turned out, we all know. One more common infodemic misinformation which was spread like wildfire was that in March 2020 you can see this tweet. So if you take a deep breath, don't worry about COVID. If you take a deep breath, hold breath for 10 seconds. If you don't have any cough, if you don't have any chest tightness, it means that there is no COVID. All right, so this is a misinformation which was spread, and this misinformation had actually costed grave, isn't it? And there is even algorithms which were developed. Even Harvard University, I believe, they started studying on how algorithms, AI algorithms, were developed in order to flag, in order to identify and flag this kind of a COVID-19 because controlling this misinformation is again a big problem, is again a very important thing. WHO has coined the term infodemic concerning all this kind of misinformation, because this is going to turn out to increase the issue of pandemic in a big way. And another big data mine that I would like to highlight is user reviews. Let's go and look into the Play Stores, Amazon, like Google Play Store or Apple App Store, and let's go and look into any app, any healthcare app. Below it, you have hundreds and thousands, and probably sometimes, lakhs or millions of reviews of users who have used that particular app. Go to a product in Amazon, a healthcare product, for example. These reviews are from healthcare products, and go to a particular product and look into the reviews. You can see thousands and thousands of reviews, and all these reviews, user reviews, give us an interesting input, and that input is nothing but data. That data which can help us decide which medical products are working in a good way, which medical products are not working in a good way, which medical products have which kind of issues and where they should be addressed, isn't it? For example, these are the reviews of the COVID self-testing kits, right? Very recent reviews, January reviews, and they say that, or a good number of reviews say, some of the kits are not actually working. People, when they are buying this COVID kits in e-marketplaces, they are receiving faulty kits, or the kits which don't have enough sensitivity and specificity, which is a big challenge out there, because e-marketplaces serve a very big chunk of people, particularly those who are living in areas with COVID restrictions, isn't it? And self-testing plays a prominent role there. And if the kits there which are going are not the right kits, then it's a big problem, isn't it? In addition to it, in public facilities also, there are a good number of rapid testing kits which are being used, which would be deployed in the long run. So the effectiveness of those kits again could be looked into by studying in detail this, right? So overall, there are several platforms out there, right? You have social media platforms like Facebook, Twitter, Reddit, forums particularly. You have e-retailers like Amazon, Flipkart. You have e-medicine retailers like NetMeds, Pharmacy, Indian context. And you have telemedicine applications like Practo, and government ones are essential. So these are just few examples to bring your attention of the enormous amount of user data that is generated, an enormous amount of user interaction data, health related data that is generated. And manually analyzing all this data is impossible. All the reviews, all the experiences, all the posts reflect the perceptions of the users. They reflect the sentiments of the users. They reflect the emotions of the users. They reflect the attitudes of the users. And capturing them is very important in terms of making effective healthcare delivery decisions. And this is where sentiment analysis, MI and AI platforms can actually help in terms of addressing this bigger challenge, because the data is a lot. Doing it manually is not going to work, is not going to. Sentiment analysis is one approach, one of the many approaches which can actually help in analyzing, right? So what are the steps involved out there? So I believe that you all know majority of the steps out there, but to summarize in simple sense, you have 5 simple steps of conducting a sentiment analysis. I request you to kindly look into it for a second and we will discuss on. Kindly look into the diagram. Right. So by and large, when we talk about conducting a sentiment analysis, first the process starts with the whole process of identifying your potential data sources and collecting the data from them. So what's your objective? Well, my objective is to understand a particular concept like vaccine, what do you say, acceptance of a vaccination, acceptance of a COVID vaccination, right? Or my objective is to understand what are perceptions of individuals on COVID-induced lockdown. Or my objective is to understand what or how do people use Twitter to discuss about mental health issues. Right, mental health is a big problem, isn't it? In recent budget, also there was a big package concerning mental health. So mental health issues are a big problem. So my objective is to identify how do people use Twitter to communicate, to discuss, to talk about the challenge of mental health issues. That's my objective, for example. So I start with the data collection. I start with the data collection sources. My source could be, Twitter feeds. My source could be Facebook posts. My source could be Wikipedia posts. My source could be Reddit forums, Insta posts, and all this. So I took Twitter, for example. And once the data sources are identified, we start to collect the data. So how do we do it? We basically do the data collection by using the extraction APIs, and we use often some keywords. Like say, for example, mental health, depression, anxiety. In case if you are doing a marketing research, you can use some other keywords as well. Using the keywords, we are going to extract all this information, right? So APIs, I believe they mean application processing interfaces, application programming or processing interfaces, and they will help you extract all your posts. And once those information are extracted, what you can do is that you can do something which is called as a pre-processing of it. So pre-processing is basically a scenario where we process or we clean this data. So for example, in tweets, you might be having the tweets which might be having a hashtag, like say for example, vaccination. But the tweet might be in Hindi, which might be difficult to analyze, right? Or in some other local language like Telugu, for example, which might be very difficult to analyze if we are not from Telugu. Similar, or it might be difficult to analyze by a computer algorithm. Similarly, say for example, you might be having tweets which are abusive in some cases because they are user generated content. Similarly, you might be having some information which are using some emojis or emotions, which might not be analyzable to a great extent, right? So these kind of information we have to extract. We have to extract the tweet info data tweets, for example. We have to do a tokenization. We have to clean the information. We have to normalize them, and then we do the analysis part. So during analysis, often we look into the polarity, we look into the sentiment, and we look into the frequency. We can develop that particular program. Often you guys know more than it, right? So more than me about it. So you can develop that particular program and look into the polarity of that particular tweet or that particular information, and accordingly you can derive the frequency. And based on that you can report your result. So overall, these are simple 5 basic steps in which sentiment analysis is done. The more detailed information on how it has been done in healthcare context is given in this particular document, which I have cited here. So the article reflects on that in a greater detail. So we can look into it afterwards as well. So overall, using these, we can answer multiple different kinds of questions or using this particular procedure. So certain questions like, can we predict the number of cases of a disease in real time during an epidemic? So during an epidemic, can we, or when the epidemic cycles are happening, like say for example, influenza has a cycle, isn't it? Influenza or a common flu has a cycle in every country. It doesn't happen haphazardly. It happens during a season, during the influenza season, the cases peak and then they fall. Similarly, malaria, for example, it happens in a seasonal way. Dengue, for example, happens in a seasonal way. So can we predict the number of cases of a disease in real time during using, the user generated content and information? What effect does, say for example, the interventions like lockdowns and quarantines have on the people? What are the effectiveness and safety of health technology? For example, health technology assessment is an emerging field, and a good amount of data on health technology is generated online. So sentiment analysis actually helps there in terms of looking into the effectiveness and safety. And how does the views or experiences of people change over a period of time during the pandemic? So these are some of the questions that will be answered. So I had three case studies. So three studies that I have identified, we have reviewed, and I would like to help us understand the application of this procedure of sentiment analysis in healthcare settings by on the basis of these three case studies. These are only a very tip of or a very small sample of several hundreds of studies that has been done already. Right. So the first study is by these authors David and Paul. DA is for David there, and who in from USA, from United States of America, and their study was to look into the national and subnational surveillance of influenza. Influenza, as you know, it's a flu, isn't it? So what they wanted to do is that they wanted to predict, they wanted to create an algorithm. They want using sentiment analysis approach, they wanted to analyze and create an algorithm which can actually predict the number of cases based on the Twitter posts which are made in the United States. Right. So for 2012 to 2013 influenza season, what they did is that they developed a program, they developed an algorithm, and using that algorithm, they tried to review and analyze. They tried to analyze the Twitter posts that are being posted, and accordingly, they wanted to see if they were able to identify what do you say the influenza pandemic or not. And interestingly, what happened is that they were able to detect the weekly change in the direction of influenza prevalence. Like either the number of cases will go down or either the number of cases will go up, right? So they were able to detect that direction of change of cases, either increase in number or a decrease in number with more than 85% of accuracy. And they were able to identify the prevalence of influenza across multiple cities, and until the level of municipality, like they were able to overlay it with the geotag data, and they were also able to identify this number across the municipality. And what they have understood was that what they did is that they triangulated this information, they compared this information that they generated based on their algorithm, which did a sentiment analysis of Twitter data, with the number of cases that has been identified through the CDCs, the Centers for Disease Control, which is the apex body for infectious disease surveillance in USA, with CDC's output surveillance data. And when they compared both of it, what they have found was that the surveillance estimates were very closely linked to that of the CDC estimate as well. Like as I have said, it is around 85%. So here they have given an interesting graph out there that we all can see it here. So just a second. So they have given an interesting graph out there. So in this graph, you can see that this thick blue line, it is the infections which were detected by their algorithm, which did the sentiment analysis. Whereas the thick black line were the infections which were reported in the outpatient center. Thick blue line is the infections which were detected by the algorithm, and thick black line was the infections which were detected by the CDC. And all the influenza tweets, like say for example, tweets which were neutral, just information sharing kind of tweets, tweets which were you know just using the term influenza anywhere, or tweets which were unrelated or not sufficient enough in order to predict the actual case, they were very high, as you can see here. They were excluded, but excluding them, they were, this particular algorithm that these people have developed was able to detect the cases to a great extent, right? So this is one very interesting case study here. So however, what we have to understand is that it is not the same always, right? As we move ahead, we will be discussing it in one of the challenges as well. There is a very recent study on COVID-19 which was done in European countries, and they tried to do the same. They tried to look into how how the COVID-19 case graph and how the number of tweets that are being tweeted are correlated with each other. And what they have found out was that the peak in the number of tweets concerned with COVID-19 were usually succeeding the peak of COVID-19 cases. So first, the number of cases of COVID-19 rises, and following it, 4 or 5 days later, the number of tweets about COVID-19 and the fear of COVID-19 then increases. So what they have identified is that when we are using data of Twitter, for example, or any other social media post, for example, to predict an outbreak, one big challenge is that in the timings before the peak, it is very difficult to predict an outbreak, particularly when people are not very much concerned about it. But during the peak and during the high incidence of that particular disease, often the number of tweets or the data from the tweets or the social media posts are often interacting or correlated with the actual number of cases. Right. So this is one interesting observation, like a contrary to what this case study says. But overall, there is a potential for improvement in this area. The surveillance could actually be done through sentiment analysis. There is a potential for a lot of potential for improvement in this area. However, syndromic surveillance could be done, and in public health, syndromic surveillance is one of the important tools that we use in order to predict a potential epidemic in any geography. The other one is an interesting case study which was done by Pastor and K in 2020. So this case or this analysis was done uh, in Philippines, where their objective was to employ sentiment analysis to identify the experience of individuals during COVID-induced lockdowns in Philippines. Particularly, they looked into the experience of individuals during the first 3 weeks of COVID-19 induced lockdowns in Philippines. And what they have seen is that majority of the tweets or majority of the information that has been put forward by the participants, they were negative in nature. So with regard to lockdowns, the response to lockdowns was largely negative. That's what they have concluded. And what they have said is that lockdowns in Philippines has resulted in a scenario where individuals were only worrying. A lot of people were worrying about the food shortage. They were worrying about the possible situation of future. They were worrying about the potential, health issues that they are facing. They were worrying about the, supply chains that has been cut off. And most of users, they are looking forward for a possible government help that can, help them to ease the situation. So this was a study which was trying to look into the extreme community sentiment analysis, or what are the emotions of Filipinos with regard to the extreme effect of community quarantine due to COVID-induced pandemic, or due to the COVID pandemic. And it was published in April 13, 2020. Right, this was the time during which we were still juggling with the lockdowns, isn't it? So this was the, and then there is another interesting. So this study did not employ Twitters like the earlier study, but this study has employed an online support group discussion, right? So breast cancer is one of the most prevalent cancers out there, right? Including in India, among the cancers, breast cancer accounts for a significant chunk after the oral and after the oral and other cancers, right? Breast cancer among females account for a significant chunk of cancer burden, including in India. So when we talk about cancer, there are several therapies around it. One of the types of therapy is adjuvant hormonal therapy, and they use a drug called as tamoxifen. So this particular study that they have done was trying to use the what do you say, online support group information, support group chats, in order to analyze the sentiment, in order to analyze the sentiments of individuals on their communication about tamoxifen. The problem that they have identified was that this drug tamoxifen was very effective drug. It's very effective in terms of improving the cancer survivability. However, more than 50% of the women of the cancer patients were not taking it. So they wanted to understand why it is so. So they analyzed communicating about this particular drug. So they have taken the data of around 6,000 women who were part of online cancer support group, and they have analyzed their discussions. They have analyzed their chats. And what they have identified was that the women who were most active were often the women who were in the lower stages of cancer, whereas the women who were least active were often the women who were in the higher stages. And second thing, what they have identified was that with regard to the women who were most active, there were more holistic attitudes which were coming out, whereas the women who were least active, more negative attitudes were coming out, right? For example, if we see women who were most active were using the terms like we, were more concerned with friends, were more concerned with family, right? Whereas the women who were least active were more concerned with anxiety, were more concerned with sadness, were more concerned with causation, were more concerned with tentativeness, and they were more concerned with exclusion, right? So overall, what this study has identified was that women who were least active in the online forms, they often faced with a greater emotional challenge with regard to the cancer treatment that is going on, with regard to the breast cancer scenario. And they also were often the ones who were not taking the treatment to the most extent. They also were the ones who were skipping it. So what they have identified was that within the support groups also, the women who were less active were being more emotional, and they were not taking the treatment with it. So they were able to identify. And they employed sentiment analysis, and they analyzed this online forums. So overall, these were some three interesting studies that have that caught my observation with regard to applying sentiment analysis in healthcare. Well, two of them are largely with regard to the COVID, with regard to the infectious disease scenario, whereas one was with regard to the consumption of a particular health drug, the consumption of a particular drug of that. So overall, with regard to the use of this idea of sentiment analysis, what are the challenges? First thing is that it is a lot of times majority of literature, particularly with regard to sentiment analysis in healthcare, uses the data from social media, particularly data like Twitter. And because of that, we have a challenge that it's a user generated content. And within the user generated content, it has all the challenges of user generating content, including the temporality. That is, the activity happens first and then the content comes later. The person becomes sick first and then the data comes later on. So that gives us that the time lag, and that time lag is often resulting into some erroneous observation. Then the quality of data is a big problem. For example, the issue of Twitter chatter. That's an interesting term that the authors used in one of the studies. Individuals, they use rant, they use language which is sarcastic. They use language which gives a negative attitude, but which is in a different tone altogether. And there is no uniformity, and lot of emotions are used, lot of symbols are used, symbolisms are used, and because of that, the data quality gets compromised. A big challenge is that majority of the social media or user generated data that we use has the issue of digital divide, as you all know, and representativeness of the sample that we are analyzing is a big challenge. For example, if I want to analyze vaccine hesitancy of a particular country, it's very difficult because I'm going to be only reflecting the individuals who are using Twitter, right? Or who are using only Facebook, or who are using only a type of social media that I'm analyzing. But it could not be possible that people are present in that particular social media. And again, we have issues with inconsistencies in data. There is a big challenge with regard to the bot generated data, right? So a lot of data, a lot of tweets, or a lot of reviews are often bot generated ones, or fake reviews, for example, for products. So that is one big challenge. And another big challenge is that a lot of experts out there, they work in silos. For example, with regard to healthcare, we have several experts who are there in medical colleges. We have experts who are there in healthcare, health management, public health. With regard to the approaches like machine learning, data mining, big data analytics, sentiment analysis, which are very applicable in terms of analyzing these kind of healthcare problems and analyzing this kind of data, we have the experts who are there in the field of engineering, who are in the engineering department, who are in the computer science department. And these different experts are working in silos. And that's one very big challenge in terms of, using this big data gold mine over there and come up with conclusions which are able to solve the real issues in the world. So this is one big challenge. So with these things, I would like to conclude, and I would like to highlight that healthcare in India currently, particularly, is rapidly digitalizing, and I strongly believe that it is destined to be improved by the data science, and it is where I strongly believe that all of us should come together in the long run. So with that, I conclude. These are some interesting readings that I have come across while I was preparing for this work, and I believe that they'll also be of some help for you guys. Thank you very much. That's it from my end. So I think we can take a few questions as well. Like, yeah, I thought that we'll be having an interactive session kind of thing. So half of it would be my presentation, and the later half would be some kind of a discussion and inputs and thoughts from your end as well. So yes, it's done from my end. So yes, we can have a discussion. Any questions, I'll be very happy to take with regard to my area of competence, and any comments also, I request you to please do give.
Participants, please respond. You can ask questions.
Hello.
Uh, yes.
Yeah, hello, sir. I am new to this area, sentiment analysis. I have never read about this. So, do the people who do the sentiment analysis they take real-time data from Twitter and all these sites for doing so?
Madam, like what they do is that we often extract the data from a particular period of time. Like, say, for example, when we are talking about what do you say, the coronavirus, for example. So, if we want to look into a particular issue like vaccination, we want to look into the specific issue like uh, acceptance of a vaccination among a group of people, that is, among Indian community, we have to have a date. Like vaccine started being rolled out in last year, right? So from last year January, for example, until today, we have to take the test. So we can give the dates. In the earlier study that I have given, the first case study that I have reported, they what they did is that once they made the algorithm, they took the tweets in real time. So they have written an API, they have put an algorithm, and that algorithm was taking the tweets in real time, which were posted according to their criteria. So that was a real time extraction that they have done. But normally we can give the dates and we can.
Okay. So, do we have data like in Kaggle and UCI repository for sentiment analysis?
I think it is there, madam. I'm not
Oh,
very sure of it, but I think it is.
okay. Because right till now, I was just thinking that people must be taking the data from the websites, like Twitter and all, always for doing this.
No, madam, it's not just that. There are some other
Okay.
ways also, but
Okay.
thank you.
Okay. Okay. Thank you, sir.
Thank you.
Maybe some standard data sets are available in Kaggle and ECA repositories, or else depends on your case study, you have to extract from the social network through
Okay.
some APIs,
Okay.
right,
Okay.
sir?
Yes, sir.
Using
Yes,
some
sir. Yes, sir.
APIs.
Using
Yes.
APIs, we
Okay.
have done.
Okay. Okay.
Mm. Yes, please, some more questions, please. Who are working on the NLP site can ask.
Uh, Sir,
Naturally.
Jagadish Kumar sir has asked several questions.
Some questions are there in chat box. You look it, sir.
Yes, 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 sir.
Uh, mm,
So Jagadish Kumar sir's first question is that there are
mm,
several instances of paid reviews. How can we set a threshold to keep this at minimum? Sir, this is very interesting question, sir. The thing is that particularly with regard to customers, there are several instances of paid reviews. One thing is like often Amazon or any other e-commerce sites, platforms, or these people, they have means by which they can check the paid reviews. However, when we are talking about platforms like Google Play Store or any other app store where the reviews are being posted, the paid reviews are a big challenge. So for that, probably we ourselves have to put a criteria within our algorithm that uh, reviews with these kind of characteristics should not be included in the this is the final in the analysis part. During the data cleaning procedure, we have to work around it, and that goes the same with the fake reviews also. Like if we can identify the fake reviews, like say for example, if we know that a particular organization or a particular group of individuals, the reviews are more loop-sided, they are more skewed, or they are more impacting our data, we can put that filter and we can make sure that those group of individuals or those group of organizations, those group of reviews can be excluded, or reviews with that particular kind of a hashtag will be removed. And cross messaging platforms are actually, there are studies, even there are even studies which were trying to use multiple platforms like Twitter post plus Instagram post, for example, in order to look into the mental health crisis. There has been some very interesting research that has been done in the last 5 years. They triangulated the data from the Twitter post and the Instagram post to look into that. And retweets and reposts also can be handled, so right, they are considered as one single tweet. Each tweet is considered as one single tweet, and depending upon the algorithm that we make, and that could be done. Madam, the silos, what is working in silos? Working in silos means, madam, working individually without any interaction, without any knowledge of what each other are doing. Like, say, for example, I work on a problem of healthcare. Like, I work on a problem of healthcare. I work on a problem. I work on a healthcare problem. Say, for example, Arogya Setu. We all might have installed it, right? So, how Indians reacted to Arogya Setu? That is my question, right? So, I am a public health guy. So, I don't have the methodological competence to really to really extract all the user reviews and to really do a good sentiment analysis or an ML based analysis of the user reviews. So what I do is that I individually take a sample of reviews, say for example 500 reviews or 1000 reviews, and I manually analyze all those individual reviews one by one, and based on that I say that okay, fine, Arogya Setu is well accepted by the people, or Arogya Setu is not well accepted, and A, B, C, D are the challenges. However, in case if I have done this same work in collaboration with another faculty, say for example Kumar sir, who knows about my ML tools, so machine learning tools. In that regard, probably he can help me extract and do it using an algorithm, and in that way I can extract all the tweets or all the what do you say user reviews rather than just one or two, or rather than few hundred user reviews. So that will give me more precision if I had worked along with. So working in silos is working individually. So until I publish and until I come up with the publication, Kumar sir does not know that, yeah, this fellow is working on this. And in case if he had known, he could have helped me out in terms of, coming up with a strategy, an ML based strategy in order to do the work more efficiently. So working in silos is that challenge. Similarly, for computer science people, you have the tools out there, but probably what kind of healthcare challenges could be addressed or should be addressed using these tools. Maybe that might be a lacunae for computer science individuals, and that's where the public health or medicine or healthcare people can help you out in terms of identifying a potential area where this particular tool could be applied concerning the healthcare. So that's how it is. Kalamani Subramani is asking a question. I'm working on sentiment analysis for a drug data set. Is it available in Kaggle? Actually, I'm not very sure about it, but I have to check it.
No, sir, this is for Neetu ma'am, sir.
Okay.
She asked no, yes, sir.
Please, any more questions, please? Sir, you can also suggest some medical data sets available as a medical practitioner, as a social health people, where to look for data sets, medical
Sir,
data sets.
currently, sir, a good amount of our work is being inclined towards uh, like taking in the data from the existing reviews itself. So, like say for
Uh,
example, the Twitter
uh,
reviews and all. We are working on one very interesting document
um,
on vaccination. So
mhm.
for that, we are using Twitter as a platform to extract the data. We have a team which has written its API, and
Not only in social networks, sir, other standard data sets, which repositories you will look. Just like computer science people will go to UCR or UCI, Kaggle,
yes,
like
sir.
that some repositories are there. For you also, any other repositories regarding
Uh,
the medical data sets?
for
Uh,
us, sir, for that we often go ahead with NFHS, TLHS, census.
uh,
These kind of data sets we use. Sir.
Sir, please write in the comment box so that people will note down.
Yes, sir.
If anybody want a medical data sets,
Yes, sir. Yes, sir.
they can download.
So
But
NFHS, DLHS, that lastly, WHO says. Sir, I have entered some names:
Yes, yes, sir.
NFHS, DLHS, GATS,
Mm.
LASI, WHS, and DHS.
Oh.
These are some of the most commonly used data sets in the medical literature. Sir.
Okay, okay. Those are available, na? Directly
Yes,
if
sir.
you
They
type
are
it,
publicly available. Sir.
publicly
All of them are
available.
publicly available.
Okay.
Lastly, we have to write to them with an application. Sir. Like we have to just write to the parent institute by entering the specific data set and they will do.
Sir, if you type NFHS, it is available, na? Google.
Yes, sir. Yes.
Or else any repository name is there, website name like
No,
that.
sir. It will directly redirect us.
From
It will
Google, we
directly
can
redirect.
directly go to that website.
Yes. Sir.
And regarding the, sir, my doubt also regarding the, what is cardiac data sets, cancer data sets, like that is available now.
Yes, sir.
We will refer Kaggle only, Kaggle, UCR, UCI only for that. Any other sources are there to get the information about the
Sir,
cardiac
for cancer, sir, we have cancer
cancer?
registries. Sir. We have cancer registries which are maintained by ICMR.
Okay, okay.
So they have the information regarding all the cancer cases, and most of the big cancer hospitals maintain those cancer registries, and that data goes back to ICMR, and that is all.
Our students also tried, went to some hospitals and asked, they are not giving.
Yes, sir.
Yeah. So we always depending on the standard data sets.
Yes.
Publicly available data sets only.
With regard to, sir, if you want to, if anyone wants to do some work on tobacco control, particularly tobacco related predictive analysis, because nowadays tobacco use is a very big challenge. So for that, GATS, Global Adult Tobacco Survey, is a very big very big data set. It has data from almost all the countries, and it's publicly available, easily available. There are more than 400 plus variables for each country.
Okay.
So some very good analysis could be done through that data.
Computer science people, most of the people will concentrate on the cancer, breast cancer, other types of cancer predictions.
Yes.
Next, heart disease prediction and Alzheimer's prediction. Most of the depends on the prediction side only. Prediction and classification. For that, standard data sets available for us, so mostly will depend on that only.
Yes.
Sir, as a social public health faculty members, any suggestions to computer science teachers?
Sir, no suggestions. Sir. One thing is that, sir, in the next 10 years, particularly in the next decade, it's going to be a big transformation in healthcare field. Like in 2020's Independence Day address, our
Sweta, please unmute your mic.
डाटा सायन्स अर्ज केलं होतं ॲटलवर.
Shweta, please unmute your mic.
Right, sir.
Okay, sir.
Right. Yeah, in 2020 Independence Day address also, Narendra Modi ji was talking about the launch of National Digital Health Mission. So National E-Health Authority is one such institute, and then Ayushman Bharat Digital Mission is another one. So a lot of interventions are being launched from the top government side also regarding digitalization of health. So this is the area where computer science and the engineering people can actually, work very closely with healthcare. The next 10 years are going to be very transformative. For example, from my own work that I have seen, sir, one of the very big challenges with regard to healthcare data keeping is the interoperability. Like, say for example, take an example of the maternal and child health data itself. The data is collected at the state level, and this data is essential for the central level record keeping as well. Like, say for example, Niti Aayog requires a lot of this information, lot of this data. But the state level way of data keeping and the central level way of data keeping are totally different. Like I have seen, like I was interacting with some of the stakeholders who were managing this. So at state level, what happened was that they were using a platform called as ANMDG. It was 2 years ago. They were using a platform called ANMDG in order to collect the data. At central level, they were using a platform called as RCH portal to collect the same data on pregnancies, childbirth, and all of that. So when they tried to synchronize the data from the state collected portal into the central collected portal, the data was not synchronized. The reason was that the basic architecture of how this data was collected and this data was collected was different. For example, for a PHC, here the code was given as 01. Here, for in central government database, the PHC's code was given different, and that was preventing the syncing of the data. And that has created a very big problem where at the grassroots level, the ANMs or the ASHAs who were really collecting the information on data has to do a double work. They had to do a manual entry. They had to do enter in the electronic database in the state system separately, and they had to enter in the RCH portal system separately for the central. So they had to basically do 3 times data entry just because there was a small challenge out there with regard to interoperability between the two different systems, the state and the central. So this is a very small problem. One of the challenges that I have seen, a very small challenge that could be easily addressed, but has a very significant impact in the way how the data is collected and kept. So now, this is one very small problem. There are several of such issues, several of such problems across the country and across the building blocks of health system. And that's where I think healthcare and computer science, particularly programming, has a very big role to play. And we all can join hands regarding that.
Okay, thank you, sir. Thank you. Participants, any more discussions?
Even sir, the big names, big journals like IEEE is also coming up with a lot of good publications in this frontiers of digital healthcare. So they are also encouraging it a lot, and even in healthcare as well. For example, from the healthcare side, for example, Lancet is a very big publishing house. We all know it. It's a very reputed big publishing house. Even Lancet has come up with recently with a publication 2 or 3 years ago, a journal called Digital Health from its, where it is inviting computer science and digital and health related publications. Like the publications where computer science and health related people are coming together and publishing.
Okay, sir. I hope no questions from the audience side. Thank you, sir. Dr. Prakash Babu Kodali, sir, from Public Health Department, Central University of Kerala, have delivered a wonderful lecture on a sentiment analysis in facilitating pandemic preparedness. And he given a very detailed talk on that. Even though Sar is not from the computer science department, he selected a sentiment analysis. He explained the cycle of the procedure analysis, how to extract the data from the social networks and how to pre-process it and how to prepare the model and how to predict it and how to use the results and everything explained in a clear manner. And he has also shown some case studies on that sentiment analysis. I hope it will be useful to you. Most of the people related to working on the sentiment analysis and natural language processing, it will be useful. I hope everybody enjoyed the session. On behalf of the Department of Computer Science and on behalf of the participants, thank you very much, sir. Thank you for your wonderful lecture and spending 1.5 hour time with us. Thank you very much, sir. Thank you, Prakash, sir.
Thank you very much, sir. It was
Thank
a wonderful opportunity
Thank
for
you.
interacting with all the faculty members out there.
Yes,
I'm
sir.
really sorry if I am not able to meet your demands, particularly the rest of all other big faculty members.
No, sir.
Thank,
No.
Thank you.
You met our demands. Only practical is missing. Remaining everything will be reached.
Yes.
Yeah. Implementation only. Okay. Thank you, sir. Thank you very much.
Okay, sir. Thank you very much, sir.
Thank you
We
very
look
much. Thank
forward
you.
to seeing you all
Yeah,
here.
sir.
Thank you,
Yes,
sir.
yes. We are expecting you in future also in our
Thank you.
programs. Thank you, sir. Thank you very much. Thank you, participants. That's about the today's session. Manas, are you there?
Yes, sir.
Please post your feedback form.
Yes, sir. I already posted.
Okay.
Okay.
All of you fill that feedback form before leaving. And whatever the PPTs we received from the resource persons, will send through the group mail and through the WhatsApp. Okay, and video links also we will send through group mail. And anything else? If nothing is there, we will meet tomorrow morning for the 6th session at 10 o'clock. Okay. All of you fill the Google form. It is available up to 4 o'clock. There is no link between the feedback form and the attendance. Attendance is tracking automatically here. At the beginning, we will start tracking. At the end of the session, we'll stop the tracking. So it will show for total 1.5 hour how much time you attended. You connected to this conference, virtual conference, virtual meeting. Okay. Thank you, guys. Thank you. We'll meet tomorrow.
Thank you, sir.
Thank you. Thank you.